It's one of the strangest aspects of human sensation. You can't tickle yourself, no matter how hard you try. The exact same touch that would send you into uncontrollable laughter when done by someone else does absolutely nothing when you do it yourself. This isn't just a curious quirk. It reveals a fundamental mechanism of how your brain constructs your entire reality, moment by moment. Most people assume tickling is simply about the physical sensation, that certain body parts are more sensitive than others, or that the unpredictability of someone else tickling you creates the response. Some believe it's purely about the social aspect of tickling as a playful interaction. While these factors play a role, they don't explain why identical physical touch produces completely different sensations depending on who does the touching. The answer lies in a sophisticated neurological mechanism that constantly distinguishes between self-generated and external sensations. A system so fundamental that when it malfunctions, it can contribute to serious psychiatric conditions. The key to why you can't tickle yourself lies in a small but crucial part of your brain called the cerebellum. According to research from University College London, whenever you make a voluntary movement, your cerebellum sends out a precise prediction of what sensations that movement will cause. When your prediction matches the actual sensory input that follows, such as when you touch yourself, your brain significantly dampens the sensation. This phenomenon, called sensory attenuation, reduces the intensity of expected sensations by up to 80% compared to identical unexpected touches. Neuroscientists have directly observed this process using functional MRI brain scanning. When someone else tickles you, your somatosensory cortex and anterior cingulate cortex, brain regions involved in touch sensation and pleasure processing, show high activity. When you attempt to tickle yourself, these same regions show dramatically reduced activity. In a clever experiment, researchers at the University of California created a robot-mediated tickling system where participants could control a robotic arm that tickled them. When the movement and resulting sensation were perfectly synchronized, ticklishness was minimal. But when researchers introduced even a slight delay between movement and sensation, breaking the prediction chain, participants suddenly became ticklish to their own actions. This predictive mechanism serves critical evolutionary functions. First, it helps distinguish between self-generated sensations and external stimuli that might signal danger or important environmental information. Your brain needs to filter out the constant sensory noise from your own movements to remain alert to external threats. Second, it provides continuous feedback about your body's position and movement in space, essential for coordination and motor learning. By comparing predicted sensations with actual outcomes, your brain fine-tunes its internal models, allowing for precise control of complex movements. The same mechanism explains other sensory phenomena beyond tickling. For instance, you can't effectively startle yourself, and the sound of your own voice in recordings seems strange because you normally hear it through both air and bone conduction, which your brain predicts and adjusts for. Perhaps most surprising is that tickling requires an element of surprise or uncertainty to be effective. When researchers at the University of California, San Diego told participants exactly where and when they would be tickled, the tickling sensation was significantly reduced compared to unpredictable tickling, even though the physical touch was identical. This self-monitoring system is part of a broader predictive processing framework that neuroscientists now believe is fundamental to how our brains work. According to this model, your brain constantly generates predictions about incoming sensory information and updates these models based on errors. When this system malfunctions, the results can be profound. Research from the University of Cambridge found that people with schizophrenia who sometimes experience difficulty distinguishing between self-generated and external stimuli can often tickle themselves. Their predictive models fail to properly dampen self-generated sensations, contributing to symptoms like auditory hallucinations. The system also explains why tickling is inherently social. Tickling games evolved as a way to practice defensive responses and build social bonds in a safe context. Studies of rat ultrasonic vocalizations, their version of laughter, show they make these sounds during playful tickling interactions and social play, suggesting ticklishness evolved as a social bonding mechanism across multiple species. Even more fascinating, this prediction system may be fundamental to our sense of self and agency. By constantly distinguishing between self-generated and external sensations, it helps create the boundary between self and environment that defines our bodily experience. So, the simple fact that you can't tickle yourself reveals something profound about how your brain works. It's constantly creating predictive models of the world, filtering sensations, and distinguishing between self and other. This fundamental mechanism shapes your entire conscious experience, usually operating completely below your awareness. Next time someone tickles you, remember that your laughter isn't just about the physical sensation. It's about your brain being genuinely surprised by a touch it couldn't predict, engaging ancient evolutionary systems designed to help you process unexpected stimulation in a social context. If you found this revelation eye-opening, hit subscribe for more I Bet You Didn't Know videos that expose the unexpected truth behind everyday experiences.